Dear students, in this video lecture, we are going to discuss about data and signals. What is data? What is signals? How to represent the data and how to represent the signals. We will see the presentation now. So this data and signal topics comes under classroom discussion topic 3 in unit 1. So before starting this discussion about the data and signal, what is the outcome for this lecture? So after listening to this video lecture, you will sketch data and signals and classify the types of data and signals. Okay, this is the outcome of this video lecture. So first we are going to discuss about analog and digital data. Okay, data can be represented. Data may be analog data or digital data. Okay. So the term analog data, what is analog data? Analog data means it's information that is continuous. Where the information is continuous, the data is considered as analog data. Where the information is discrete, that is considered as a digital data. Okay. So here, how we can say that? If the data is continuous, okay. So for example, we don't know where it will be over. It's going like this. This is the analog data. Continuous data. Okay. So continuous data means continuously it is there. But digital data is discrete data. Discrete data means we know the values. For example, 1010. Okay. So how we can represent 1010? Okay. So we can represent like discrete values, that is digital data. In analog values are continuous. So for example, for analog data, the analog clock, okay, so some needles are there, it is rotating continuously. Okay, so it's have the hour, minute, and seconds, and gives information in a continuous form. Okay, there is no stop, continuously it is running. Okay, 24 hours. Then again it will start from 0, 1, 2, 3, 4, 5, 6, 7, 8, like. Okay. The movements of the hands are continuous in the clock. That's why that is the analog clock. So on the other hand, digital clock. So we know that the digital clock, yes. So digital clock may be represent the time direct. Okay. So it represent the digits. Okay. So represent the digital values in the digital clock. So analog means continuous, digital means discrete. You just remember it. Okay. So now analog data, such as sounds made by a human voice, take on continuous values. Okay. So if I'm speaking something, okay, it will generate some sounds. We don't know how to represent this data. When someone speaks, an analog wave is created. When I'm speaking, the analog wave is created, okay, in the air. This can be captured by the microphone and converted to an analog signal or sampled and converted to the digital signals. Okay, how my voice is recorded in the computer? I'm using the mic. My voice is generating the signal in the air that will be recorded and passed through the microphone to the computer. The signal will be converted into the binary form, zeros and ones. Then it is stored in the computer. Okay. So that is analog data. Digital data. So already we discussed about digital data means it's a discrete values. So examples, data are stored in the computer memory in zeros and ones. We know that if whatever I'm talking, that will be stored in the computer. How it is stored? The signal will be converted into the binary form that is stored in the computer. Okay. They can be converted to the digital signal or modulated into analog signal for transmission across the medium. Whenever the data wants to transmit it, that time it will convert it to digital data to analog signals. Okay. Whenever it is recorded, that will be converted analog signal to digital data. Okay, that we have to remember it. Clear. So now we are going to discuss about analog and digital signals. Okay, so previously we had discussed about data. Now we are discussing about signals. Like the data, it is also have analog and digital. So either signal also classified into analog signal or digital signals. Okay. An analog signal has infinitely many levels of intensity over a period of time. Okay. How we are represent the analog signal? So using the sine waveforms. The infinitive, we don't know going. Okay. So intensity over the period of time. So the time may be mentioned in the over of time how the signals are moving. As the wave moves from a value A to value B, it passes through and includes an infinite number of values along its path. Okay. So this is the A, this is the B. So in between, this time, the waves are transmitted. So this is analog signals. Digital signals, on the other hand, can have only limited number of defined values. Okay, limited number of defined values. So we know discrete values. So what we are discussed in the digital data, that's a discrete values. So although each value can be any number, it is often a simple zeros and ones. If any value converted into zeros and ones or binary forms, okay, both are same. The simplest way to say the signal is by plotting them on a pair of perpendicular axes. Okay. So we can write normally can use this perpendicular axis. The vertical axis represents the value or strength of the signal and horizontal axis represents the time. So this horizontal axis represents the time and this vertical axis represents the strength of the signals. Okay. So how much value it is going up. Okay. So it will be represent the strength of the signals. So now we are going to discuss with the diagram. So see this diagram. In this diagram, this is the analog signal. Okay, so it is a continuous signal. So there is suddenly it is increased or decreased. The wave also more. We don't know when it is increased, when it is decreased. Okay, so there is no proper values. It is continuous values. Okay, that's why we are saying that analog signal. Analog signal may be represented using the sine wave. So this wave may be represented as sine wave. So this is the digital signal. So here we know that some values are there. Okay. So the vertical lines of the digital signals demonstrate the sudden jump that signal makes from value to value. For example, it may be 0, it may be 1. Okay. So it may be 2. Okay. So it may be -1. So something. Okay. So what happened here? This form 1 to 0, suddenly it is coming 0, then 0 to 2, then 2 to 0, then 0 to 1, -1, like that suddenly it is jumps. This is the digital signals. But the curve representing analog signal passes through infinity number of points. Okay. So we don't know how it is connected, how many points are there in the connection of these lines. the continuous values. Okay. Now we are going to discuss about periodic and non-periodic signal. What is periodic signal? What is non-periodic signal? So both analog and digital signals, both analog and digital signals can take one of two forms. What are the forms? That is the periodic signal or non-periodic signal. In non-periodic signal, we can say that aperiodic. Okay. So aperiodic or non-periodic, both are same. So both digital signal and analog signals may be take in the form of periodic and non-periodic. What is periodic signal? Periodic signal completes a pattern within a measurable time frame called a period and repeats that pattern over subsequent identical periods. Okay, so for example, we know that strength we will use the vertical, this horizontal may be used for time. So this is the signal may be used like this. Okay, so same height and same. So this is the period. In the particular periods, the pattern is same, measurable. Okay, so it is same. It's a measurable. So it will be continued for furthers also. Same height and same lower and higher like that. We're going like this. So this is the periodic signal. The completion of one full pattern is called cycle. So it is example you can consider the degree 0 degree, okay, 90 degree, 180 degree, and 270 degree, 360 degree. Where the 360 degree, the complete pattern. So this is called like cycle. Okay. So this is means up to this one cycle. So we can represent periodic signal with the same pattern. What is non-periodic signal? Non-periodic signal changes without exhibiting a pattern or cycle that repeats over the time. Okay. So what is that? So example, we can say that symbols are there. So it may be that. So like this. Okay, this is aperiodic signal. There is no common pattern. So whenever it increased, whenever it is decreased, we don't know. So this is we can represent aperiodic signal like this. Okay. So over period of time may be changed in many points. Both analog and digital signals can be periodic or non-periodic. Both the signals may be represented as periodic and non-periodic signals. In data communication, we commonly use periodic analog signals and non-periodic digital signals. You just remember that. Periodic analog signals, non-periodic digital signals. In data communication, we are using this one. Okay. In end of this lecture, now we are going to discuss about lecture outcomes. So end of this lecture, now you know how to draw the data and signals using sine waves or different forms like the perpendicular axis. So now you are able to sketch the data and signals and able to classify it is periodic or non-periodic signal, it's a digital data or analog data, it's a digital signal or analog signal, like you are able to classify it. Okay, this outcome of this lecture. The simple questions I posted for your rethinking. What is aperiodic signal? So non-periodic and aperiodic signals are same. The patterns are not same at entire period. That is non-periodic signals. Differentiate digital data and digital signals. Okay. So digital data means zeros and ones. So we are using sudden changes of in waveform, that is called like digital signals. Okay. So sine wave used to represent the analog signals. Okay. So thank you very much for listening this video. The next classroom discussion topic is digital signals that we will discuss in the next video. Thank you very much for listening.